Welcome back, and in this lecture what we're going to do is we're going to talk about MIDI. So what is MIDI? And the very beginning brings us back to the 1970s in the very first electronic musical instruments, okay? So basically they all had a problem because they were coming from multiple different manufacturers. They all had different fittings, they all had different inputs and outputs. There was different connecting leads for all the different devices. There was all different types of circuitry because they were using all different sorts of chips and boards and so on and so forth. They had different types of power sources as well. Some were plugs, some were the big plug, some were an IEC device, so on and so forth. It was a mess. So as more exciting range of instruments came out, especially synthesizers, which were an explosion in the 70s, of course, with Jean-Michel Jarre and people like this doing mad stuff with synthesizers, we had to have a way of basically streamlining the production process and making the most out of it for everybody. So the problem obviously was the incompatibility with the plugs and the connections. So essentially what happened was a collaboration between the Japanese and American synth makers who combined to develop a standard that would be usable across all these new synthesizers and electronic music making devices. So the idea was all manufacturers would basically follow in designing and creating electronic musical instruments and devices that were similar. All the new devices would be flexible and more interconnectable to get the most from them. So all synths, as we come to the 1980s, all synths now use the same type of cable. They all have the same types of inputs and outputs. Internally, each device would speak the same language, and the input and output information is sent out in a set format so that it can be interpreted and reinterpreted by multiple devices down the line, and everybody understands what everybody else is saying. So essentially, the collaboration outcome produced completely compatible instruments. Score. And this is just absolutely game-changing in the world of music, as I'm sure you're well aware. So the synths and the keyboards, it's now possible to link multiples together using MIDI cables, and the new protocol pass back and forth between connected machines as musical information. So it's now a new protocol, it's now a new computer language that these synthesizers are actually talking to each other with so that they can communicate musical information. MIDI interfaces are actually what allows the MIDI information to be passed between MIDI-enabled musical instruments and computers now in both directions. So this is the communication device, the hardware device that actually allows this communication. So obviously that pushes on then towards music software, because I just mentioned music computers. And musicians could now record and create entire compositions using many different instruments and sounds now using the computers and the synthesizers together. This is just game changing, as I said already. The ability to alter any part of the performance in isolation then by amending the MIDI data is also game changing, because you can change the velocity, you can change the length of the note. Oh, I hit one bum note, let's go in there and just change that one note. Otherwise the recording was perfect. Again, game changing for most people back in the 80s and the 70s. So MIDI's reach is now, you can do MIDI controllable lighting rigs. You can have a look at the lighting course that's close to this one as well. So MIDI now has a greater reach. It's also usable for MIDI controllable lighting rigs. We've got MIDI control surfaces that meant a keyboard player could basically press one key or one note in the middle of the performance. The whole lighting sequence would then change. And this is the start of synchronization and having lighting in synchronization with the music at the shows. Back in the 80s, I'm sure that was absolutely mind-bending. So hardware then. We basically have new cables, connectors and connections that are now all standard. The protocol, we've given birth to MIDI. It's a language that's spoken by these synthesizers and MIDI-enabled devices, which means a series of musical instruments can have musical instructions sent from one place to another about how to play and perform musical sound as it was originally captured, as it was originally programmed. So moving on then to the MIDI hardware, and a big part of this is the MIDI cable. You can see the pin configuration on the left of the actual slides. It's a round 5-pin DIN plug. Only 3 of the actual pins are used. Pins 4 and 5 carry the actual MIDI information. Pin 2 is the earth or the ground, so it has the same configuration thus far as an XLR. And then pins 1 and 3 are completely unused, but are included for future development. We might see those get used in MIDI 2.0, who knows. So ports and connections then, this is the actual MIDI devices on the back of your MIDI enabled device, such as a synthesizer, for example. So each MIDI device has at least one connection on it, otherwise it's not a MIDI device, duh. And that is more than likely, if you only have one, it is MIDI in. It more or less always is, unless it's a MIDI out, which is in rare cases. Just like the picture of my MIDI keyboard, a lot of devices actually have three. There's MIDI in, MIDI out, and MIDI through. We'll talk about each one of those in a moment. There's obviously new ports and connections now. What you'll see there is a MIDI in, MIDI out to USB connector. MIDI can be transported obviously over USB then, and this is one of the most popular methods that we'll see these days. A lot of the devices that use USB for converting to MIDI also do so to take power as well, so you don't even need to plug them in now, a lot of devices these days. And as it says there, most devices are plug and play. USB also provides power for the device. So MIDI in, this port receives the MIDI information. MIDI goes in this port, pretty straightforward. MIDI out, all the information about notes or actions played on the keyboard of a MIDI device are sent out through this port, self-explanatory. And MIDI through, this port provides an exact copy of the MIDI data received in the in port. Okay, that's important. MIDI through doesn't produce anything of new note. It just gives you a direct out, a direct copy of anything that goes in the in. It doesn't give you what goes out the out. It just gives you a copy of what goes in the in, back out, through the through. Passes it through. So MIDI through versus MIDI out, we'll just go a bit more detail on that one. MIDI through allows one stream of musical instruction to flow from one instrument unchanged through and a number of connected devices. Each device in the chain receives the exact same information then that is generated by the very first MIDI device as it passes it through the chain down through all the different devices to affect them all the same, or for them to ignore, of course. One MIDI configuration that is very popular is called a daisy chain, and that's exactly what we're doing. MIDI through ports are essential to this. That's exactly what we're talking about when we talk about MIDI through ports. So basically, the information is going to go in one, out to through, in the next, out to through, in the next, out to through, and so on. A daisy chain. It flows on down the chain, down to the very last one. Of course, if there's no through port on any particular device, make sure it's last in the chain so that I can take the MIDI in. So beyond MIDI, we've got new protocols now that we actually use, because protocols are obviously the thing that we're talking about most here. And OSC, or Open Sound Control, is one of them. It's being created for sharing music performance data between musical instruments. However, OSC is at higher performance and at resolutions, and it can run over wireless and wired networks. Personally, I use it on an iPad for when I'm controlling various applications that are running on the actual Mac, that I can use this then for performance. I can run around with the iPad in my hand and still trigger events and so on and so forth. You can also use it, of course, to trigger lighting and visuals and so on and so forth. That's for another course. MLAN is the Music Local Area Network. It's based upon Firewire. It's owned and developed by Yamaha. It's used by over 100 manufacturers. Again, just another protocol that is allowing devices to talk to each other in the same language to achieve musical ends. The HD protocol, this is the new MIDI standard. Maybe this is what we'll see the extra 2 pins used for. It is going to be fully backwards compatible. Of course, it's going to use the same hardware it would be. It also supports modern data speed transfers. So maybe it'll use a completely new cable, who knows. We also see an increase in the number of channels, but it is still in production. It's not arrived yet. We wait with a bated breath to see what kind of functionality that's going to give us. That's it for MIDI. That's the whole thing. Go look it up more if you want. There's lots and lots of information out there. Since the 70s, we've been using the same protocol, the same information in the same ways. That'll tell you just how good it was and how forward thinking they were at the time. Get stuck into it. It's massive for synchronization and for music production these days. You can't live without it. Get to know it. See you in the next lecture.